यस मैम।
मैंने लास्ट कौन सा प्रैक्टिकल करवाया था?
मैम आपने बोला था कि वो डीएफएस वाला हम ट्राई करेंगे इम्प्लीमेंट करने का, वाटर जग प्रॉब्लम डीएफएस।
जो प्रॉब्लम्स है। अच्छा, मैंने डायग्नोसिस सिस्टम वाला प्रैक्टिकल करवाया था आप लोगों को?
नो मैम।
नहीं करवाया था ना, डायग्नोसिस सिस्टम वाला बाकी है। ठीक है, मैं दिखाती हूँ, वो फाइल शेयर करती हूँ आप लोगों के साथ। वो तो आपको वो प्रैक्टिकल कंप्लीट करना है। दूसरी चीज उसके बाद आता है हिल क्लाइंबिंग एल्गोरिदम, ए स्टार एल्गोरिदम। वो सारे मतलब क्या है कि मैंने बेस्ट फर्स्ट सर्च एल्गोरिदम, ओके, ए स्टार बाकी होगा। बाकी के एल्गोरिदम्स मैंने आपको करवाना स्टार्ट कर दिया आपके प्रैक्टिकल लिस्ट में। मैं स्क्रीन शेयर करके दिखा देती हूँ तो कौन सा बाकी है और कौन सा करेंगे आज। ये लिस्ट वाला तो हो चुका था ना, ऑपरेशंस इन लिस्ट?
यस मैम।
Okay, so this 7.1 you guys need to do it on your own because ये class में चल चुका। I have explained you the depth first search and breadth first search tree. Then in Queen's problem I will explain you today. Best first search, this is already done in your class. So for today you keep this target of doing n Queen's problem and this 7.4. 7.2 and 7.4 must be done by you today because those two algorithms are taught to you in detail in your class. The same graph was a similar kind of graph was given to you for the best first search in your class, and how to find the shortest path, it was demonstrated. So that you need to do on your own. And n-Queen's problem, I will explain you n-Queen's problem, the heuristic function I will give you. The rest of the things you need to figure it out on your own. Now, talking about this, I have not explained you this particular prologue program of medical diagnosis system. So I'll give you the file and then you can test it out on your own how this particular thing works. Okay, so wait for 1 to 2 minutes till I share my screen with you regarding this. Okay. Look on my screen for the explanation of the program. That is medical diagnosis system. Okay. Here you need to keep your concentration on three predicates. The first one is go. See, this will execute this sub goals. The first sub goal is write. You are asking for patient name. This write and read predicates are well known to you. Okay. Then it makes a cause to hypothesis predicate. So hypothesis predicate is written over here. That if the patient is having following symptoms, fever, headache, runny nose, and rash, then we can say the patient is having German measles. The symptoms are written over here. Okay. The symptom is written over here that if the patient is having fever, rash, headache, you are asking, you are taking a single character, yes or no, Y or N. Okay. So if the patient is having these symptoms, then we basis on the symptoms entered. Okay, I basis on the symptoms, yes. Okay, I will be storing the value, and those will be verified with the hypothesis that patient is having fever. Okay, yes. Headache, yes. Then body ache, yes. So then the patient might be having flu. When we consult this file over here, so you need to write the predicate go, because that is what makes the sub goals written in go predicate to execute. So what is the patient name? It is Shrintu. Okay. I am having fever. Okay, yes. Headache? No. For yes. Okay. Runny nose? No. Don't forget to put a full stop after that. Okay. Sneezing? No. Cough? No. Body? Yes. Conjunctivitis? No. One? No. Pills? Yes. Rash? No. Sorry, I don't seem to able to diagnose the disease. If it depends on the combination, yes and no. If it is matching the hypothesis, okay. So let's just try for some other thing. I need to close this and run it again. As the problem with this is what, because this is using our main memory, everything gets stored over here. So the fact is directly from the main memory. Let's put yes, no combination. Again it is given. So you just put the values and you see it is going to give you some data or not. Okay. Just now I did one combination. I'll just show you. So, and you probably must be thinking from where this is, why it is asking only for 4. Okay. Because in the code somewhere I have written asking for the similar symptoms only. Okay. That code you will find over here in verify. Here there is ask. See, if there is a symptom, okay, then it will ask for that particular uh, patient and symptom detail. Okay. Basically, here you will see two predicates that you have not seen previously. Assert. Assert means you are placing the question, and here when you retract, assert and retract. That means you are removing that question. So with the assert predicate, so when this ask predicate is getting called, with assert, the question is being placed, and with retract, the question is being removed from. So if you are placing fever is equals to no, then whatever the related symptoms related to the fever, because after symptoms, what we are going to call is verify. And for the verify, again, that's true or false. So again, we are going to call it for ask over here, and ask will assert a question. But if this particular verify fails, then we are going to do undo, and undo will retract the question. So placing a question and removing the question is handled by this particular piece of. So when you place fever is equals to no, then few symptoms are removed. The questions related to the symptoms are removed, and that is because of this retract. So assert means you are placing the question, and retract means you are removing that question. So try it out. This code I'm giving you. Probably you might be successful for getting any disease combination. I tried it and I got few answers, but right now you just tried it. Okay, I'm attaching this code in your chat box. The code is attached in your chat box. Now n queens problem. Okay, I'll show you the n queens problem. Look at my screen for n queens problem. I'm going to explain you the problem. I'm going to give you the heuristic function value, and you can use hill climbing code, but heuristic function is the one you are going to use, which I'm giving you. See, n queens problem is like you are having a checkboard over here, and you are supposed to place n queens on it, such that no two queens can kill each other or attack each other. The position should be such that all four queens should be safe on your checkboard. And that is the game. That all four queens should be on the checkboard. So here, you need, if n is equals to 4, then you will be having 4 cross 4 chessboard. And you have to place 4 queens on the chessboard in such a manner that all 4 queens should remain same. No two queens can attack each other. Okay? This is a one kind of optimization problem, and this can be solved using hill climbing algorithm. Okay, the heuristic function over here is you are going to use is the one I'm writing in your chat box. Okay, so h of n, that is equals to number of open squares. The heuristic function for solving n queen problems you are going to use is number of open squares. So let's start with the initial state. The initial state would be you are placing one queen. Okay, you know that the queen can attack in horizontal, vertical, and diagonal. Okay, so all those squares where the queen can attack are marked with the crossed. Now open square, you count the number of open square. It is very easy for us to count the open square. Okay, that is 1, 2, 3, 4, 5, 6. So when you place first queen on the chessboard, only 6 open squares are left where the queen cannot attack, and you have to place the other queen over there. Okay, no two queens should be in same column, no two queens should be placed in same row or in diagonal. This is the rule. Okay, so you can consider like a matrix. I'm giving you out the hints over here. It is a matrix. if you are placing a queen in a row or a column, so the other queen must not be placed in that row, column or diagonal. So we cross out all those. And there are only other 6 open board positions are left with us after this. So what we do over here is place the other queen in this. And then now again those 3 constraints, row, column and diagonal, eliminate. So after placing the second queen, only 3 open positions are left. Hill climbing where it helps. See, this is a minimizing kind of a problem. If the heuristic function value, first it was 6, now it was 3, the move is acceptable. But if the first it was 6 and the next value you are getting is 7, the move is not accepted, the algorithm fails. Okay? So that is not going to work. So after placing second queen, 3 open positions are left where you can place the queen. So same row, column and diagonal not allowed. Okay, placing the third and fourth. The final solution should be like this, where no queen can attack each other. And this is the game you need to play in this particular practice. Clear? Clear about this? You have heuristic function, you have knowledge about, say I give you this particular website name so that you can be sure about the end-to-end problem. Okay, so you have this heuristic function, problem description, and you can use hill climbing algorithm. Okay, you don't need to code it from the scratch, but just make sure that you use this heuristic function, that is number of open square, because this is the only function which gives you informed search. The other functions are there for the same problem, but those make the search uninformed. And we need to do hill climbing in an informed manner, that is heuristic manner. That is why. Uninformed means it is not heuristic. Clear about this?
Yes, ma'am.
Yes. The third problem today we are going to see is the best first search algorithm. That is 7.4. So this 3 must be practicals must be completed. What is in 7.4? It is best first search algorithm. Okay. And if you need to find a path from A to any other node in your algorithm, you must be using best first search algorithm. The data structure that we use for best first search algorithm is the priority queue or mean or max hit. So depending on which your familiarity with the data structure you can use. I think priority queue is the one you should be using. It will be very easy for you to code and find the shortest path using this particular algorithm. Best first search. Any questions? How algorithm works, that is already taught to you in the classroom. Any question? Okay, if no question, then I would like to check your files. If anybody has completed your file until practical 5, then they can show me those 5 practicals, or I'll give you half an hour to complete your file until practical 5. So then after I will like to check your files. Okay. So if it is quite surprising, then we will have evaluation from this lab onwards. So whatever I am going to teach you the practicals for the next week, it should be completed with the 7.4. So I like to evaluate roll number wise. Okay. So I give you half an hour. If you are not prepared, start preparing the file. And after half an hour, whosoever has completed the file, they can show me and I will evaluate and place the mark. Okay. Meanwhile, I'm muting my mic. If anybody is having questions still, they can ask me. Because it must be completed today. Next week onwards, every lab, your evaluation of your file will go on. Mini project. Okay, it is of 15 marks in your pedagogy. At the start of the term, I discussed, and you can also find it in the folder A to Z evaluation patterns and pedagogy. So you would be having AI project to be doing. It is of 15 marks, so it is not don't need to do a very huge thing. It can be as simple as sentiment analysis in NLP. Okay, so if you want to consider your this practical of NLP to be considered under the mini project, then also it can be considered. Okay, because that portion is also covered in the expert talk and in your lectures with Chirag Patel sir. Okay, so you can consider it as a mini project and present to me in the upcoming labs. So depending on your completion, you can do it. Okay. I would request an AI project of your choice. So for the next lab, I'm scheduling the presentation. So those who are able to complete the project within the 1 week or even with the 15 days duration, they can show. See the project again, it is not needed to be a huge one. As it is of only 15 marks, make the scope of project equal to 15 marks only. Don't go for a huge thing. See, 10 marks practical we do, implement BFS, AFS algorithm. For a 15 marks, you decide a very small definition, implement the idea, and that's it. Nothing more is asked to you. Okay? Even a chatbot with some good answers can also be considered as AI project. So from next lab onwards, I will start with the presentations. Any queries the students can ask me.
मैम हमारा एसजीपी का प्रोजेक्ट एनएलपी बेस्ड है, चैटबॉट है और हम 3 लोग हैं, तो हम मिनी प्रोजेक्ट में ही वही बता सकते हैं?
Yes, why not? बता सकते हैं.
हम 3 लोग हैं पर.
हाँ चलेगा.
ओके मैम, थैंक यू.
Your presenter, show your file.
यस मैम.
Or you are having question?
फाइल.
Okay. You are presenter, show me. Share your screen.
इज इट विजिबल मैम?
Yes.
नीचे जवा दो मैम.
Scroll down. Where is your roll number? In the screenshot I mentioned there should be your roll number. Scroll it down. This is practical 1. Part I cannot
1.2.
see anything. Scroll it down. I cannot see any screenshots over here with your roll number.
मतलब रोल नंबर मतलब
Your roll number should be in the screenshot using right predicate. It proves that you have run this program.
सारे प्रोग्राम है वो लैपटॉप में, कहते हो तो वो दिखा दो.
That doesn't mean that you have executed them. It can be downloaded.
नहीं मैम, ये पाथ भी देखो, ये मेरा वाला ही है.
ऐसे कैसे? यहाँ तो आपका सिस्टम का नाम भी नहीं दिख रहा है पाथ में. तो
ड्राइव में है मैम, इसलिए.
वही तो, ऐसा कुछ तो प्रूफ होना चाहिए ना. आई थिंक यू नीड टू चेंज द स्क्रीनशॉट्स.
सारे चेंज कर. नीचे वाले भी मैंने ही किए।
तो रन ही तो करना है प्रोग्राम, पहले से ही पता ही तो था, मैम ने स्ट्रिक्ट इंस्ट्रक्शंस दिए थे। If in screenshots I don't find your roll number, then there is no meaning.
ओके, मैं करता हूँ।
नेक्स्ट वीक चेक कर लूंगी पार।
ओके मैम।
सॉरी।